Have you ever stood in your backyard, looked up, and watched a massive commercial airliner glide silently overhead? It's a sight we see every day, but it still begs a really big question. How exactly do 100,000 pounds of metal stay suspended up there instead of just falling back to Earth? The secret starts with how we think about the sky itself. Instead of picturing empty space, imagine that the air around us is actually a thick, physical fluid, behaving a whole lot like water. Viewed this way, the airplane reveals itself as a specialized creature, engineered to navigate the currents of this invisible ocean. From a slow-moving blimp to a hovering helicopter, every one of these machines relies on the exact same basic anatomy to survive in that fluid. To understand the magic of how we fly, we just need to take a closer look at the shared skeleton, muscles, and balance of these incredible machines. If you peel back that outer skin of aluminum or modern carbon fiber, you reveal the complex, rigid skeleton holding the entire structure together, known as the airframe. The main body of this skeleton is called the fuselage. Think of this as the central cavity of our creature, built strong enough to protect all the vital internal components, the cargo and the passengers inside. From that main body, primary appendages extend outward. These are the wings, and their specific job is to slice through the air and create the upward push needed to support the heavy body. At the very back, we find the empennage, or the tail section. These vertical and horizontal pieces work exactly like the feathers on the back of a dart, keeping the whole machine pointing straight. This specific skeletal layout gives the aircraft the exact shape and stiffness it needs to withstand the intense rushing pressures of the sky. So how does this heavy skeleton actually move? The moment an aircraft leaves the ground, it enters a constant four-way tug-of-war with its environment. The first force is weight. This is the inescapable pull of gravity, grabbing onto the total mass of the airplane, passengers, and fuel, dragging it all straight down. To fight gravity, the wings slice through our fluid ocean of air to create a powerful upward force called lift. Lift directly opposes weight, pushing the belly of the plane toward the stars. As the plane pushes through that thick air, it encounters friction. We call this drag. It is the resistance of the wind pushing back against the metal body, trying to slow the aircraft down. To overcome that backward friction, the aircraft needs thrust. This is the raw forward push that drives the machine ahead. Cruising smoothly at 30,000 feet is a deliberate state of equilibrium, where these four aggressive forces entirely cancel each other out. To generate that forward thrust, our flying creature needs serious muscle. In aviation, we call these power plants. Smaller, slower aircraft usually rely on reciprocating engines. These work a lot like the engine in your car, using internal pistons to spin a propeller attached to the front hub, physically pulling the plane through the air. Massive commercial jets require a different kind of muscle, the gas turbine engine. This complex piece of machinery continuously sucks in a massive amount of air, heats it up with fuel, and blasts it out the back at high speed to propel the heavy jet forward. But massive muscles and a strong skeleton mean nothing if the creature lacks coordination. It has to know how to balance. This diagram shows the math behind that balance. The crosshair icon on the wing represents the center of gravity. This is the exact pivot point where the entire weight of the aircraft, all the items listed in this data table, is perfectly concentrated. Think of it like balancing a seesaw. If you load too many heavy suitcases in the back of the cargo hold, that pivot point shifts too far toward the tail. The nose is forced up, and the aircraft can lose its ability to steer. Because of this, strict mathematical load planning serves as the aircraft's inner ear, ensuring the machine maintains its physical equilibrium before it ever leaves the ground. Of course, a creature this complex needs dedicated medical care. That is the job of aviation maintenance technicians. These highly trained specialists follow rigorous, legally mandated checklists. They inspect the metal skeleton, test the engine muscles, and check the outer skin for microscopic signs of wear and tear, ensuring the machine is healthy for its next swim. When everything is finally cleared for departure, the massive aircraft lines up and rapidly accelerates down the long asphalt runway. Those massive engine muscles roar to life, creating an overwhelming amount of forward thrust that easily slices through the atmospheric drag. As the sheer speed of the aircraft increases, the air rushes over the wings, generating a massive, powerful upward lift. Finally, that lift overpowers the downward pull of weight, pushing the balanced skeleton up into the sky. The next time you board a flight, you're stepping inside a muscular marvel, a machine tuned to perfection to conquer the invisible ocean above us.